have, look, no, this is not. We need to go through separation techniques for this. Some of these actually require additional information, right? For example, these, which one's atom, which one's molecule. This one is our topic, right? So let's just have a look at few of the questions and then we'll delve into the new topic. Okay. Question number 15. What are the processes W, X, Y, and Z in the following diagram? Right? Solid to liquid is W, liquid to gas is X, then back Z, and then Y. Yes, Mariam. A, B, and C. You've got 4 options. Which one do you opt for? C. Okay. Melting, boiling, freezing, and condensing. I would disagree. In a way. Of sorts. Okay. Let's go with this. Okay. In this case, this is melting. Okay. And this is, oh, Y, sorry, yeah, the Y is here, sorry, yeah, you're right. Sorry, I was going for the, freezing and the condensation, thinking that this is condensation and then it's freezing, so, but this order is different, right? Oh, because of this order, I just got it wrong. Okay, fine, you're correct, good. Okay, moving on. Bromine, yeah, this is our question. A gas jar, bromine vapor, and a gas jar of air are set up in this diagram, right, with the separator in between them. You remove the separator and the gases will just mix up, right? Which statement explains why the bromine and air mix together? Bromine is denser than air. Bromine is lighter than air. Bromine molecules moved upwards and molecules in air moved downwards. No. Molecules in bromine and air moved randomly. Which one would you opt for? It's going to be D. Bromine is not lighter, by the way. It's heavier than air. It just falls down, right? Compared to air. If you just, invert this jar and don't spill it over, you'll see that the brown cloud will just start to swirl around and just spread over, right? Because it's heavier than air. What is the difference is that it moves randomly, and this random movement, random directional movement, is what you call as another way of defining diffusion, right? This is basically bromine diffused with air, right? Because they had space. Now before they didn't. If you remember the particle experiment we did, remember, on PhET simulation, where the particles were moving, and when I removed the separator, they started mixing up together, right, after a while, even though one was heavy, one was light. Red and the blue particles that we were working with. Okay, question 17. An attempt was made to compress a gas and a solid using same apparatus, using this apparatus, right? We have a piston, we have a gas. Which substance could be compressed, and what is the reason for this? Yes, which can be compressed? Gas, because the particles are very far apart. Correct. Okay. Is there a way a solid can be compressed? Have you ever seen a solid getting compressed? Come on, you sleep on it. Mattresses, they're solids, aren't they? But they get compressed. Yeah. So yeah, don't forget basic science. And why that being solid compresses? Just a random question over here. Scientific query. Foam. Yeah. Because it is foam. Why the foam is able to compress? Why can compress a foam? Even though it's solid. Plastic. Come on, it's got air particles in there. It's foamy, na? The name foam means we bubble air through it while making this. So that some of that bubble just, stays in there while it is liquid form, right? And once it's solidified quickly, then all those air bubbles, they just stay entrapped in it, and that air bubbles actually get compressed when you press this foam down. It's not the foam that is getting compressed, the plastic is not getting compressed, it's the air inside that plastic that gets compressed, giving you a cushiony feel that you get, right? The cushion. So keep that in mind, right? So yeah, there may be some solids which can be compressed, and that is still not due to the fact that the solid particles are getting compressed. Maybe it's got another medium inside it that has the ability to get compressed. All right, are you clear? Okay. This one, 18. This is a much better representation in the form of particles. That was colored, and this Two jars of gas contain the gas jars are connected and the cover slips are removed. The diagram shows what happened to the particles of the gases. This is what has happened to the particles of the gases, black and the white. This happened. Which process has occurred? A, B, C, D. Chemical reaction, condensation, diffusion, evaporation. What do you think? Yes. Mariam, are you there? Oh, I actually get diffusion नहीं हो सकता. Diffusion हो सकता है. Yes, diffusion ही होगा. Because condensation में तो एक particle नीचे बैठ जाना चाहिए था ना आपके पास, right? One particle would be sitting at the back. Condensation means liquid formation. So liquid would be sitting at the bottom, would be flying around. Okay, chemical reaction, then the particles would have joined together. Let's say one black, one white, right? Whatever the configuration, right? They should have made a new type of molecule, not staying independent. Okay, evaporation, that again involves a liquid. So this is wrong, this is wrong, this is again wrong. Okay, another question. What type of gas do you see for both? Let's say, let's call this as A or B. I give you a theoretical question. What type of gas do you think A and B are? What do you think? I'll give you options, two options. Monatomic or diatomic gases. And why I'm calling it gases? Because the particles are spread out, right? Solids and liquids don't do this. They need to be centered at the bottom. So these are gases for sure. That we can predict from the diagram. Monatomic gases, very good. And those would be noble gases for you, right? We'll get to know why they are no monatomic and why we call them as noble gases, right? So these are noble gases. Obviously we can't use these samples. You don't have readily available noble gases sitting in your lab. They're very expensive. Okay, the diagram shows the results of dropping a purple crystal into the water. Water, purple crystal, this is KMnO4, right? Most of the time potassium permanganate, purple crystal, also known as, by the way, it gives a purple color and it's given the name Pinky. I don't know why. I don't know what British do. Their names and their colors, they don't just match. It's called Pinky, the salt, while it leaves a purple color, right? Also used as you can say, indicator for our chemical processes, right? We use this later. Going to understand this use of this KMnO4 as an indicator as well, right? For titration processes and separation technique. Very end of our chemistry topic. Okay, after 5 hours, the color